to all in examples. This is the electromagnetic theory, and we are here for EMI, that is electromagnetic induction. So we are here for Ohm's law. For Ohm's law is valid for ohmic conductors only. So ohmic conductor like this one, we consider this as ohmic conductor because this conductor that is following Ohm's law, having length L and cross section area A. Now what is Ohm's law? Ohm's law is something when potential is directly proportional to the current. And as we remove the proportionality sign, there is some constant, that is R. R is constant, means R neither depends on I or V. Means R dependence on I and V is nothing. So R is constant here. And what R is called? R is called the resistance. Resistance. This is a solid wire and current is passing it. Okay. So it has some current density. So what is the current density? Current density, as already told you, that current per unit area that is perpendicular to the flow of current, or we can say is as cross section area. Okay, so this is what we got. Now what is the value of I? It is V over R. So it's V over R A. Fine. But when you find the potential, so how to find the potential? Potential is actually E into L. Why E into L? Because if you observe this, potential are at ends, and if electron is if current is moving, it means the charge also moving inside them, and if a charge moving, then electric field generates. Electric field generate across that length. So it's going to be E by E into L over RA. Now what is R? R is nothing but R is the resistance which is depends upon our resistance. Resistance depends upon length, and resistance depends over the cross section area. Means the thick wire has more cross section area, resistance is very low. So from these two equation, R is equals to, or R directly proportional to L by A, but as I remove the proportionality sign, it's going to R equals to rho L by A. Here rho is the constant here, and that is what we call conductivity. No, sorry, resistivity. That is called resistivity. Now we know all things, so just put the value in the J. So J becomes E L over rho, or simply rho A is what? Rho L. So that L gets cancelled out, and from here J is equals to E by rho, and 1 over rho is sigma. So J is equals to sigma E, and this is what we call as Ohm's law. This is also Ohm's law in vector form. Okay, so whenever we talk about Ohm's law in vector form, then J is equals to sigma E. Whereas simple Ohm's law, this is V equals to IR. Now we know what is, now J is equals to sigma E. We have already seen sigma is nothing but 1 over rho. Okay, so what is sigma and what is rho? So rho was your resistivity, and sigma was conductivity. Fine. This is what we have now. We have all the things. Now what we will do, we will find the differential resistance. For example, R is equals to rho L by A. So write this as a differential resistance. Differential resistance. In this, what we see that R is what? Resistance is rho L by A. Okay, resistance is rho L by A, and rho is constant, resistivity is constant, cross section area is also constant. So if I differentiate it, I got dI equals to rho dL by A. So for ideal conductor, if we see ideal conductor, what happens? Sigma is going to be infinity. Conductivity for ideal conductor is infinite, and if it means because it's very high for conductor. So this is for ideal metal, better to say ideal conductor. Okay, ideal conductor is infinite. And about what about the metals? If metals we have, then sigma is very high. Fine. Why we find this differential resistance? Because it's going to be useful in the numerical problems. Okay, that's why.